All right, 10 minutes past the hour. Welcome back, everybody. I will stop sharing my screen here. Miguel, do you want to start sharing your screen?
Okay, cool. All right, thank you, everyone. My name is Miguel de Berras. I've been predominantly involved with Mojaloop from an engineering perspective over the last 2 years or so, and I'll be taking you through a bit more of the technical overview. Some of this has already been, at least at a high level, let's say Michael has already taken you through some of this stuff from a high level perspective. So I will be going through some of the flows a little bit quicker, but just focusing on some of the detail of the parts that I think need a bit further clarifications. Okay, all right, so this is a great place to start. So if you need some links and you need some information about Mojaloop, here's a bunch of them that could help you. We've obviously got the website, we have the documentation, and we also have Slack, which many of you already are part of, but if you're not part of Slack, you are welcome to join. You can follow this link and you'll get an invite and you're able to then jump on Slack and communicate with the rest of the community. From a code perspective, it's all hosted on GitHub. You're probably already accessing some of it when you've been looking through the agendas and through some of the documentation. So you might already be familiar with that. We also have Getter, which is just open for wider community conversations. And we also have a link to some training where you can basically get some more information or deep dive into certain areas with regard to Mojaloop. Okay, so I'm going to skip this. What is Mojaloop? I'm going to move more on to here. So this is a functional overview with regard to what has been implemented so far on the open source side of things. So if you go through the Mojaloop specifications, you'll know that there's specific use cases, for example, pay-initiated transactions, bulk transactions, pay-initiated transactions, etc. And this is just a view in terms of what has been implemented, what maybe had or what is supported but maybe not fully tested yet. And that's not to say that it hasn't been tested by implementers in the wider community, but at least from the pure OSS perspective, it may not be tested. And it also indicates what maybe has been partially implemented, which most likely means that it is still being implemented as we speak. I'm happy to report that there is nothing at the moment, at least from a high-level overview, that you can see here that's not fully implemented. So that's a great place to be compared to the previous PIs. And I think this gives you a good idea of where we are. It's worth mentioning some additional use cases here that are not specifically part of the Mojaloop specification. So for example, we now support P2P transfers on us, which now is configurable on the switch. It's now optional whether you wish to enable it or disable it. Originally, the switch didn't support the on-us transfers, and now it can be configured on installation whether you wish to support it or not. We also have settlements, which supports things like funds in and funds out, as well as managing your settlement windows, which is basically a grouping of transfers in certain segments as you're processing through the life cycle of a transfer, which I'll get into a bit more detail a bit later, as well as helping you manage and operationalize your settlements as well. And we also have the ability to process and process the acknowledgements of settlements and receiving, etc. Also reconciling FSP positions and also now interchange fees. It's also worth mentioning that we now support 2 settlement models, although one still has some work in progress, but originally we supported only the deferred multilateral net settlement model. And now there's a lot of work going on to basically support the continuous gross settlement model, which you'll hear a bit more in the next coming days. Right, so just some general terms that I think is a great place to start. So we're speaking some of the same language. So a hub. So this is a general term that we use for any kind of Mojaloop switch that's implemented, that's existing in the wild, that's being used. And this includes the open source components, as well as other components that have also been implemented by the person who's hosting the hub itself, or maybe even third-party components that have been introduced into the Mojaloop switch. So basically anything that's necessary to run the actual Mojaloop or a hub per se using Mojaloop. And of course, you would expect the hub would actually adhere to some form of regulatory requirements, etc. And it would also define a set of rules, limits, reporting regulation, etc., as well as how to onboard your FSPs, etc. And that would be generally referred to as a scheme. We also have FSPs, which is in essence, or DFSPs, which is a financial service provider. So those are basically the participants that are part of the Mojaloop switch that are exacting the payments. And we also have parties, which are the customers of those FSPs. And each party or a party is represented by some kind of identifier, example, an MSISDN or an account number or even an alias, etc. And of course, a party could be just a customer on the street, or you could even think as a party as potentially even a merchant. Next slide. So we have the cryptographic receipt. So Michael already covered a little bit of this, but basically the cryptographic receipt is how the payments are validated. And you'll see that basically a fulfillment is generated, which includes or generated from some of the payment information, and that's done by the payee FSP. And a condition is basically a hash of that fulfillment, and you'll see where that's shared, or you did see where that was shared based on Michael's talk as well, and how that's used to validate. We also have the participant position. So this is a net positionable activity. So basically, as a participant is exacting payments of the system, he has a real-time position, which is either going up or down, whether he's paying or whether he's receiving funds. And this is basically for an account, a specific account for a participant, which is also specific for a currency. We have a net debit cap limit, which is basically a limit that is applied to a participant's position. And this is very much used to basically help manage some of the risk that's associated with running a switch, as well as manage the participant's risk as well, and how they interact and trade within the system as well. So by putting this net debit cap limit, we're basically ensuring that a participant is not allowed to interact or trade within the system past that limit. And of course, the way the limit is maybe set would be very much dependent on how you onboard your participants and how you run your hub. But in general, you can think of when a participant joins a hub, they would generally provide some upfront collateral to be a participant as part of that actual hub per se. And that would definitely go towards at least determining what their position may be. It's not necessarily always the case, but that's more or less how you can think of our net debit cap limit would come about. Michael's already gone in detail with regard to the stages of a Mojaloop P2P transaction. So we have the discovery phase, the agreement phase, the transfer phase, etc. So I'm going to skip this. And I'll take you guys through a quick P2P scenario demo. Michael also had that in his presentation. So I'm going to also go, I'll go through this fairly quickly as well, and just kind of focus on areas where I think are important. So it's, in essence, we have the scenario where we have some customer who's a sending party who belongs to a payer participant who wants to make a payment. And he wants to send some money to his friend, which is called a Santesani, and he's otherwise known as the recipient party. And he belongs to another FSP, which is called the payee participant. And of course, to do that, we need to do a couple of other things, right? Because the payer participant doesn't know which FSP a Santesani is a customer of, so we would need to be able to resolve this by doing an account lookup. And then on top of that, we need to have the agreement part of it. So we have the payer participant who needs to agree or validate the final transfers, costs, fees, etc., and with the paying customers party as well. So we need to also initiate the quote request. So basically the transfer, the account, and the quote request. So this is just showing you quickly the lookup phase. So on the far left, we have the payer or the payer participant, who's a DFSP with his backend. He has his own ledger. And on the far right, we have the payee participant, and they have their own ledger, etc. They have a legacy backend here, and they've actually they've utilized the Mojaloop SDK to provide a scheme adapter, which basically provides an interoperability layer between their legacy backend and the Mojaloop API, as well as it also offloads all the security aspects that were mentioned there. The mutual TLS, the JWS signing and validation, etc., will be done by this on behalf of the actual participant. So on the far left, we have a payer which sends the request in for an account lookup to look up a specific party to determine which FSP they belong to, and as well as to retrieve additional information about the party itself. So we have an MSISDN here, some kind of identifier, etc. The account lookup service is going to receive that. And now inside of the Mojaloop switch itself, we have the concept of these oracles. And it's got nothing to do with the database. It's purely just a way, you can think of it as a registry, a component that provides the lookup mechanisms for a specific party identifier, as well as the participants themselves. And it also provides a pluggable architecture where one can introduce as many oracles as they want, independent of the account lookup service, and register them for certain party identifiers. So for example, there could be an oracle that's registered for MSISDNs, etc. There could be another one that's registered for account lookups, etc. And so the account lookup service will have these oracles that are registered with it, and it will be able to determine based on the party identifier which one to call. And it's basically going to query these oracles to basically resolve the participant information. So if we move along, we see that that's called, that's going to provide it, and that's how the account lookup service is going to know where to route that actual lookup party request to. And it's going to send that party request to the pay participant. They're going to resolve it, etc., as you previously saw in Michael's presentation. Let's move on to the quoting step phase. So quoting phase, we have the payer participant sending the quote to the quoting API. The quoting API will accept the request, and it will then basically call the central ledger to determine the routing information for the payee participant, which is included as part of the request that came in, since this payer participant has resolved a link between the actual party and the participant. That's now included as part of the quote itself. And the quoting API can then forward that to the payee participant. They would receive it. And this is the step where a crypto receipt is basically generated. And what I mean by that is the condition is generated based on the information, of the actual message that came in, and then the fulfillment is also provided as well. And a set of expiry is also included as part of the response as well. And that's sent through to the quoting API, back to the payer, and that concludes the actual quoting phase. Just moving on to the transfers. The request is sent from the payer, transfer API receives it, and it's then validated. And this is where certain steps you'll see that are now basically shown at the bottom here. And you'll also notice this box down here, which is also just tracking the position of the payer and the payee. So you can see how that interaction works when a transfer is exacted by the Mojaloop switch itself. So first we have a validation of the payer limit against his net debit cap to make sure he's able to do it. If he passes, the funds will then be reserved. And as part of that, we're going to update the payer position within the system. So it's now plus 100. The transfer is then sent to the payee. They receive it. And now, as part of the transfer, the condition is included since it was provided as part of the quoting. So now the payee participant is able to then check his fulfillment and do the validation against his condition to make sure they match. If they match, then the commit or the fulfillment is sent back to the switch to resolve it. The transfer API then receives it. And then since now the fulfillment is provided or shared as part of that fulfillment, we then also evaluate the condition to also confirm that it is a valid transfer itself. If that passes, we then commit the transfer, and we also add that transfer to a settlement window. So basically, at any one time within the Mojaloop switch, there is one settlement window that is active. There can only be one settlement window that's active. And whenever transfers are concluded or committed, that transfer is added to a settlement window. And it's up to the switch to manage when a settlement window is closed, and when a settlement window is closed, the new one will automatically be generated and opened. So new transfers can come in. And that is very useful, because as a hub or Mojaloop switch itself, what happens is when you create your actual settlements, you're going to create a settlement report with a collection of settlement windows that you wish to actually do the settlement itself. And that's how you kind of group your transfers per se to be able to do that. And when we now commit the transfer, we now basically do the opposite. We basically decrement the payee position by -100. So you have this ebb of flow of money coming in, positions going up, and money going out, positions going down, etc., as transfers are flowing through the system. And this, in essence, is what we call, what we refer to as real-time clearing within the Mojaloop switch itself. And also, when settlement processes occur in the background, if there was a settlement, those settlements would also impact the positions as well. As settlements occurred within the system, these positions would be reduced appropriately. So the transfer API then concludes by sending out a final fulfillment to the payer participant. And as well, there's an optional final notification back to the payee, which can be configured. And that concludes the transfer. Those ledgers are updated for the participants. So, do I have any questions there first before? I don't think so. I don't see any questions. Okay. All right. So just moving on to the high level architecture. So this is a bit more in depth in terms of how everything looks. This is very much a mirror of what you saw previously, just in one picture. It's also very much similar to what, or the steps that you saw with regard to the discovery, agreement, and the transfer itself. Those are represented by A, B, and C. And of course, you can follow these steps through the system. So for example, the account lookup service, you can follow from A1, goes through to the account lookup service, and you can see A2 to do a MSISDN lookup, etc. And then the A3 to send the request to the pay participant, etc. So you can, it's very much parallel to what you saw. It's just obviously not an interactive one, but it gives you a good oversight in terms of how the system interacts with each other. And as previously mentioned, here you can see with regard to the oracles, here are several oracles that are here. We have an oracle for an MSISDN adapter, which interacts with an external GSMA Pathfinder component to be able to resolve MSISDNs. We have another example here, which is a merchant service, which connects to a local merchant registry, some kind of database that's hosted within the Mojaloop hub itself. And even in the open source, we have an Oracle simulator, which is useful for basically doing tests, etc., and validating account lookup tests. So other thing worth mentioning as well is with regard to the transfers itself. It's a bit more complicated than what you saw on the previous slides. It's not just a transfer API. If you decompose the transfer API, it actually has two main areas, domains, should I say. There is a Mojaloop adapter, which is able to speak the Mojaloop specification API whichever version that's currently supported. At the moment, it's version 1, and we're now moving on to 1.1, which you'll also find out a bit more information through the next coming days. And it translates or decodes the message into into our internal persisted streaming platform, which we use in Kafka. And we have a host of central services which are able to pick up those messages and process them in a resilient manner, in a consistent manner, to be able to basically store the transfers, update the positions, etc. And those, depending on the outcome of each of those components, those messages will move to different topics, etc., accumulating in a final notification message that goes back through the Mojaloop adapter and to one of the FSPs as a result of that. You'll also see here a central settlement component, which interacts with the actual central database and Kafka components. It's listening for position changes. Depending on those kind of interactions, it may do things. And for example, there's also notifications that get sent out to FSPs on position changes, etc., or on settlement changes, etc. We also have in this picture a settlement scheme settlement process over here. This component over here is a custom component that the Mojaloop Hub operates. It interacts with the central settlement component, and it generates basically reports to be able to actually create the settlements, etc., and to basically collect the windows that it needs to be able to do that kind of thing, as well as send the acknowledgements back to the central settlement service to be able to also conclude those settlements. Moving on. Here we have the component architecture. So this is just basically breaking down into the physical components a bit more detail what you saw on the previous slide per se. And we have basically the core components, which is, I would say, the most interesting part of it. And this can be broken up into the account lookup service, the quote service, and as well as a whole slew of separate components that form the complete transfer services. So we have the Mojaloop adapters, for example, to handle the APIs, the notifications, and inside we have the central services themselves, which are doing the prepare requests, the position changes, admin functions, handling the fulfillments, the timeouts of actual transfers themselves, as well as GET requests for transfers. And we also have the bulk transfers, and you'll see that basically the bulk transfers are actually utilize the existing transfer components. So the bulk transfers would receive a bulk request, and it would basically break those into individual transfers, which then get processed by the existing transfer services. But the response of the bulk transfers will then correlate all the responses and send out a bulk response appropriately. We also have transactions, which you'll hear about more in the next coming days, as well as people talk about the PISP initiative. That's currently one of the key things that have been done as part of this PI. And we also have supporting components at the bottom here, which include things like central settlements, some of the pathfinders. For example, there is a Oracle Pathfinder, which interacts with Pathfinder, which is fully open source and available to anyone to use. We also have the scheme adapter, which was also mentioned that the pay participant was utilizing. And we also have some other components, for example, handling email notifications, central event processes, which is listening for certain events and sending out certain actions based on those events. We have the event stream processes, which are able to process logs, errors, audits, and tracing events throughout the system. We have an event sidecar, which is actually collecting those events and publishing them. And we also have a settlement management, which is also a component that's helping generate reports, reconning them, and basically creates also cron jobs. So if you want to automate the closing of windows, etc., you can do that through this settlement management component. We also have a finance portal UI, which is a visual way to represent a visual representation of the current transfers through the system, as well as being able to access some of the information of the switches participants. Over here, we have quality assurance domain, which includes things like functional tests through Postman, onboarding scripts, which are also done through Postman. We also have simulators to be able to actually do tests and validate switch implementations, as well as if you're a participant of a switch, you may also wish to use these simulators to confirm whether you can interact with a switch itself without actually being able to physically connect to a switch. We also have a testing toolkit, which is a UI-based way to run operational tests and visualize them and see the requests going through the system. And we also have licensing, security, and audit components that ensure our dependencies, our build artifacts in the open source are healthy and are safe. We also have some software development kits. So we have a Mojaloop SDK, and this is actually one of the key components that was used to build the scheme adapter, and that's available to anyone who wishes to use it. We have an Oracle SDK, which is used to basically create those oracles that you saw so that you can plug in to the account lookup service. And we also have an event SDK that most of our components implement, which is able to produce the audits, the logs, the traces, etc., as they're processing requests throughout the system. We also have a persistent layer here. We have a couple of different persistent stores. We have Redis, which is mainly utilized by the SDK scheme adapter as a cache. We have MongoDB, which is used mainly for the complex event processing, as well as now for some of the bulk transfers. We have MySQL, which is the main persistent store for the actual central ledger itself within the hub. And we're using Kafka for the actual message streaming. On the far left, we also have the operational monitoring capabilities. We use APM for our tracing to be able to visualize a transfer throughout the system, through all the components. We also have Elasticsearch and FluentD and Kibana to be able to collect logs in a central location, and which also provides a mechanism to index the logs, provide searching, etc., through all the logs that are generated from Mojaloop itself. And we also use Prometheus and Grafana to actually collect and visualize real-time metrics in terms of how things are operating within the system. How many transactions per second are we seeing? How long are requests taking, etc. Here we have the container management and orchestration platform. We use Helm to be able to deploy our components in a very consistent way. And it basically ends up being very much a configuration-based deployment thanks to the capabilities of Helm. We have Kubernetes, which provides our execution platform per se. It allows us to actually manage and orchestrate our containers in a very reliable fashion, as well as provides all the high availability and reliability requirements that we need to be able to run Mojaloop, and as well as provides a mechanism to be able to define policies within our actual execution environment to ensure certain requirements or constraints are met. And of course, it also provides the mechanism which allows us to run Mojaloop on-prem or on cloud or some kind of hybrid model is one of the key components that provides that capability. And of course, we have Docker, which runs our containers. And as mentioned, you can run this on AWS, Azure, on-prem, whatever your choices of infrastructure. As long as we can run Docker containers, as long as we can run Kubernetes, it can run there. In the open source, we currently use Rancher just to basically help manage our infrastructure. And since we have several Kubernetes clusters, for example, for development and for performance testing, this is just an easy management layer that helps us basically on a daily basis with the environments. On the far right, we have our continuous integration and delivery components. We have, in the near future, we're going to have infrastructure as code tools, which are going to help deploy Mojaloop by the push of a button. We have Circle CI, which is used for our testing, building, and deploying. We have Docker Hub, which contains basically the actual Docker artifacts that are built. We have NPM, which is basically where our dependencies are stored. And we also have Gitbooks, which is used for documentation. So Mojaloop is designed for scale. So you saw previously some of the flows in terms of how the system interacts with each other. This is kind of a more in-depth look with regard to just the prepare leg of a transfer. So on the top left here, we have the payer, and on the far right, we have the payee. And of course, the ML API provides a REST API. It's going to receive a request, and that request is then processed. It is then validated from a JSON schema perspective, and that message is then persisted to the prepare topic, which then, once the ML API has done that, it will then respond with an acknowledgement back to the payer to say the message was accepted. And once it's in the prepare topic, we have a prepare handler. It's going to pick up that request. It's going to do some validations. It's going to ensure the FSPs, the source and the destination FSPs are valid. It's going to also do duplicate message checks as well to make sure that no one's trying to send a duplicate message. And if everything passes, that information is also stored in the central ledger with regard to the transfer, the state, and as well as the hash of that transfer itself to also ensure that duplicate message checks are done in a performant manner in future. That message would be stored on the position topic, and we then have a position handler. The position handler at the moment supports several modes of processing. We support a pre-filtered by DFSP into buckets. So Kafka has this concept of partitions for a specific topic, and we can key those partitions by the FSP ID, which means that we ensure that a specific transfer for a specific FSP always goes to the exact same partition. So we can ensure that the similar workloads based on an FSP always arrive in the same bucket. And that means we can have dedicated position handlers that are able to process just that FSP's workload if we wish. Some of the advantages that gives us is we're able to provide some optimized processing in terms of how we do the position management, etc. We also support mixed FSP mode, which means that any position handler can pick up any transfer itself and process it regardless whether it's a different FSP. It really doesn't matter. It's able to manage that and process it. So depending on how you deploy things and depending on how you wish to operate the switch, you may choose one of these depending on your use case. In general, we find, at least when we've done performance testing in the past, the mixed FSP seems to be generally the most preferred. The position handler would then be able to read the position and the state, etc., from the central ledger, as well as do the updates for the position changes in the states of the transfer as a result of that. And of course, the position handler would also do the liquidity check, the funds reservations, as well as bulk processing, etc. And of course, we have the ML API adapter over here, which would receive it through a notification to be able to send out the request back to the payee participant. And of course, one of the key things is that every single one of these blue boxes, the ML API, the prepare handler, the position handler, etc., they're all microservices, they're all scalable. So you're able to basically ensure that you're able to operate the Mojaloop switch at a level that you need based on your performance requirements. Of course, we also chosen Kafka to make sure that we have durable messaging, etc. And you'll get a bit more detail in terms of what database, at least in the open source, that we're using in further slides down below. Fulfill is very much the same kind of thing. It's just showing the opposite flow from the payee back through to the payer participant. Same kind of steps, except now we have the functional validation done by the fulfill handler, which is also validating the source and the destination FSPs, as well as also doing for duplicate message checks, etc. The main change here is on the position handler over here, which also then assigns a transfer to a settlement window on commitment of the actual transfer itself. So I'm just going to go a bit more into some of the detail in terms of why we chose certain technologies. So why did we choose Kafka? Well, it provides a mechanism with a durable messaging stream. And that means basically we don't lose messages and basically ensures the reliability from an interconnection between our core components. One of the other key aspects of it is that it is idempotent, which means that once a message is stored in Kafka, it can't be changed. and also the ordering of those messages once they hit Kafka are also maintained. This ensures that obviously the sequence of events, if required, are there, and it's very useful for certain operations that we use within the system, specifically also on the, for example, tracing of our components, the auditing, etc. It provides those core fault-tolerant, durable, immutable capabilities that we need to ensure that those messages are there and we are able to process them. And if something happens, we can then recover and process it accordingly. So I mentioned we use MySQL for the main persistence store. In the OSS, we currently are using Percona Extra DB. And it's a fully open source platform. It provides high availability and it is scalable. And one of the key decisions as to why we chose it was that it provides a multi-master replication, and that ensures that we have zero data loss. And the other aspect is it works on-prem or on cloud, etc. Basically, it's supported by Kubernetes, by Helm deployments, etc. Why Helm? I think I already mentioned some of this. It helps us manage our complexity. Basically, it helps us do fresh installations, or whether we're doing upgrades or whether we're doing rollbacks. It's all configuration based, and it's the main component that helps us do that. And it's easy to update, and it's almost similar to basically something like, if you can think of, if you're familiar with Linux or something, or Ubuntu, if you're going to use apt-get to do an install of some components or dependencies or some applications you need, Helm very much is like that. It's very much a dependency managed system, which helps us do those installations. Only thing you need to provide is a configuration in terms of how you want to do that installation, and it will do it for you. Kubernetes, I think I already mentioned some of the stuff as to why we're using it, but I mean, in essence, it helps us manage the complexity of our environment, and more importantly, it abstracts us for the underlying infrastructure that you would generally use to run Mojaloop itself. And I like to call it infrastructure as a policy, basically in a sense where you can provide resource limits or resource quotas in terms of how you want to operate Mojaloop itself. You can ensure that certain components of the Mojaloop have the processing capabilities or resources, etc., that they need to operate within inside your cluster. And of course, it also leverages on other things that you would expect from a containerized environment. It provides the security, and Kubernetes builds on top of that by providing isolation at a network level as well, and through something that's otherwise known through as namespaces, where within the same Kubernetes environment, you can define a namespace for like development or for QA, and you can ensure that neither of them are able to actually interact with each other through security mechanisms that you can put in place. And another key component that I really like about Kubernetes is also the discoverability that it provides. Internally within the Kubernetes cluster, it has a dynamic service resolution via DNSs, and that means you deploy within a namespace, for example, and those services are very consistent in terms of how you interact with them, etc. So you don't have to know the IP address of a specific service when you do deployments. It automatically resolves itself and provides those service resolutions as a result of the underlying deployment itself. And of course, another key component is it also provides you the ability to scale. You're able to basically define policies in terms of how you wish to scale horizontally, up and down, etc. And you can provide policies in terms of how and when that should happen. So for example, if you hit certain network limits or CPU usages, etc., you can also cause Mojaloop to scale up or scale down once those CPU metrics and etc. come down appropriately. The system will also scale down appropriately. And one of the other key aspects that also Kubernetes provides is the ability to do rolling updates. So when you do an upgrade of a deployment, it's going to manage it in a way that it will deploy the new components and it will switch over for you to the replacement components in a controlled manner. And it's going to ensure that it's only going to do it once those new components have come up and they're reporting themselves as healthy, etc., which is absolutely a great thing. And in coinciding with that, you can also then use it to also roll back your changes in case there are any issues. So as I said, branches, basically we use it to help us manage our environments. In essence, branch is used to manage Kubernetes clusters themselves. So if you have the requirement where you need to have multiple Kubernetes environments and you wish to basically automate some of the installation of a Kubernetes environment, branches are useful tools to do that. In the open source, we're currently using that for those capabilities. And it provides multi-cloud, it provides on-prem, Azure, Google, etc. And it also, a key aspect that Rancher does provide that Kubernetes is somewhat lacking is the management of your RBAC or your security, etc. So it's to be able to interact with Kubernetes and manage your role-based authentication and your users and your roles, etc. Rancher provides a handy, useful, visualized UI to be able to do that, which is not something you get out of the box of Kubernetes. Not to say that you can't install another third-party tool to do that, but yeah, Rancher does that, which is very useful. So from monitoring perspective, we're using, well, real-time monitoring perspective per se, we're using Prometheus and Grafana, which is pretty much, I think, a fairly much a stable within the Kubernetes world. And it provides visibility for performance, for health and alerts of our components. And most of our components have been instrumented being used with a Prometheus library, which provides the mechanism and the hooks for Prometheus to be able to collect and provide those metrics. And you're able to basically visualize them, and you'll be able to process them and query them in a very easy manner. And I think one of the key things that we chose Prometheus is because of the low overhead per se. It's not dependent on the client pushing the metrics. It's very much having the client pulling the metric, the Prometheus pulling the metrics from the client itself when it needs to. And most of the metrics, or let's say the overhead of the metrics, is actually done in a summary fashion by histograms, which are generated by the actual clients themselves. So it becomes a statistical model that gets generated by the clients, which Prometheus brings in and is able to process it and provide meaningful information over a span of time. This is an example of some of the dashboards that we have. So for example, here we have some of the central ledger components with regard to Kafka, measuring the actual lag of the messages within the system. We also have the processing per second of each of the handlers. We also have the processing time in terms of how each of the handlers are able to, how long each handler is able to process the request, etc. And we have several different dashboards, one for the ML API, one for central ledger. We also have one for simulators. We also have dashboards to be able to view the Percona XtraDB cluster, which provides an overview of MySQL. We also have dashboards for the messaging infrastructure with regard to Kafka for the cluster monitoring and the topic overview. And we even have for Kubernetes itself to monitor the cluster and the deployments within the Kubernetes cluster itself. And this is all accessible via this link here. And there's more documentation in terms of how you install it and how you operate it. Next is Elasticsearch, or what we call in general EFK, which is basically a combination of Elasticsearch, FluentD, and Kibana. And by utilizing these three technologies, we're able to basically consume all the logs within the Kubernetes cluster. We use FluentD for actually collecting the logs themselves, which then ingests them into Elasticsearch. And we have Kibana, which is used to visualize that. And the key thing about this is we have a central location for the storage, the accessing of all the Mojaloop logs. It's a way for us to manage the log data. It's a way for us to also hook in alerts and events. And all those log files will be indexed, which means they're searchable. And it also is a place where we can easily use for tracing and troubleshooting, all that kind of stuff. Something else that's not necessarily covered here is there's a fourth component, which is also APM, which is the application monitoring framework that's provided by Elasticsearch. And that's actually where we visualize the tracing information, where we can see the request going through the ML API, through the prepare handler, fulfill, etc., position handler, and going back out. And we can visualize that through that the dashboards that APM provides. I've mentioned already Circle CI, so we're using that for the building of our of all our artifacts, of our dependencies, etc. It's also used for validation of our pull requests. So when anyone wishes to contribute code to the Mojaloop organization itself, one would set up a pull request, a request for changing code, and as part of that, a whole slew of tests will kick off, and you'll see on the next screen a visual representation of that, where we have a whole bunch of workflows and steps that are kicked off, depending on the kind of interaction that occurs within the GitHub organization itself. So for example, if someone wants a code change, they will create that pull request, and this box over here will be basically executed by Circle CI. We'll set up the actual environment and basically the parameters to be able to do the builds. And then we'll run a whole slew of tests, checking the test coverage, checking the licenses, the unit tests, the functional tests, as well as checking for vulnerabilities, and as well as doing an integration test, etc. And this is only for the pull request per se. If it is a tagged release, which means we're actually creating an artifact that will be released to the public, which can be used for deployments, then the build steps will be executed to actually build those artifacts. And then those actual physical built artifacts will have an image scan to make sure there's no vulnerabilities, which is very much the same thing you saw in this step over here. And we also have a license scan to make sure that there's no licenses that could contravene the open source licenses that we have. And then, of course, assuming those all pass, we finally publish that artifact to Docker Hub or to npm org, etc., depending on the actual repository. And of course, this is all accessible. You're able to access it via the npm. Here's the actual link. You can go there. You can see all the builds, all the pull requests, all the releases. They're all there. The history's there. The information about the license scan is there. The information about the image scan, they're all published there, as well as the results of unit tests, functional tests, etc. They're all available. Gitbooks, we use that for documentation. So if you go to the documentation repository for Mojaloop, the visual representation of that is based on Gitbooks, and it provides a way for us to represent the documentation in a markdown format, where we can embed content into that markdown format, and also provides handy plugins which we can use to generate content with regard to, for example, the sequence diagrams, which are represented by Plant UML, and the Swagger documentation, which generates the API docs, etc. And it also provides the mechanisms and the themes to provide the table of contents, the navigation, etc. And also a simple searching mechanism, which is quite handy. And lastly, we also have an overview in terms of the wider community, in terms of who has contributed to Mojaloop itself. You can see that the team is pretty much worldwide. I'm pretty sure that this is actually not updated, especially with the PISP guys coming into the mix. I'm sure that this needs a bit of work, but you can see pretty much from America, South America to Asia, Europe and Africa. We pretty much have someone almost in every continent. And you can even see the main current implementers of Mojaloop itself, the Bank of Tanzania, Mawali, which are represented here. And of course,
yeah, we have everything covered now, I think.
Sorry?
We have everything covered now, I think.
Is it? Okay.
Whole map. Yeah.
All right, cool. And I think that concludes the technical overview. Do we have any questions?
Thanks, Miguel. I don't see any questions in the Q&A. There are a couple of clarifications in the chat, but I'll give it a minute to see if anybody has any questions.
Okay. If anyone is not sure about anything or has questions, if they're not answering here, feel free to join the Mojaloop Slack. Feel free to ping me or even ask the questions on the open channels, etc. people are very keen to answer and assist. So yeah, by all means, feel free to join the community. It'd be great to hear from you guys.
Excellent. Thanks so much, Miguel. I appreciate your time and your presentation here. We've come to just about 1 minute past our finish time. So I want to give everybody, I want to say thank you for joining us today. I'm just sharing my screen here to give you an overview of what's happening tomorrow. Tomorrow, the conference officially kicks off. By now, you probably have picked up on the idea that day one, this particular day, was to give everybody a brief introduction and overview of exactly what the level 1 principles is and Mojaloop, both from a business overview and a technical overview that we've just completed. Most of tomorrow's updates will begin with updates from within the foundation, beginning with updates from Paula Hunter, the Executive Director of Mojaloop Foundation. I'll follow her with a couple of very exciting community updates. And we've got a number of business and advocacy sessions scheduled. I do want to highlight one particular one. There's been lots of interest from folks from the fintech community. There is a session tomorrow at 1:50 p.m. UTC that's being led by Innocent Kawoya. And he's been interacting with fintechs over the last 40 days. And there's some interesting lessons to learn about that. I think you heard earlier, a number of use cases were generated out of that. I remember John Mark highlighting that. So that would be an interesting session to plug into. We do have a couple of others in here. So I do urge you to go to mojaloop.io/decks, that's DECKS. On there, you'll find the agenda for tomorrow and a couple of other things that you'll find there. Later on, I've seen in the chat many people asking questions around the recordings for this session. Those will be available at the end of the day. It takes about 3 to 5 hours to process all the recordings, but as soon as we have them, they'll be posted in the agenda under each session. So please feel free to look at those. The sessions also have links to the decks that the presentations that have been made. In case you're looking for those presentations to read in your own time, please feel free to follow through any of the links under each of those sessions. Those are the major highlights I have for this time. Unless there's anybody with a question in the chat, I think we will wrap this up. I don't know if Kim, you'd like to jump in here for a second with any updates?
No, I think we're good. Thank you.
Awesome.
Appreciate it.
Excellent. Tomorrow we start at 11 a.m. UTC. Looking forward to seeing you all. Have a good rest of your day, night, morning, wherever you are in the world. Take care, everyone. Thanks.